Okay, it's time to get started. Thank you everyone for joining our live lecture today. My name is Isaac and I'll be the lead instructor for the lecture. And today's topic will be database foundations in NoSQL. So let's go ahead and let's start off by talking about what is a NoSQL database, okay? And in its simplest form, a NoSQL database is a database that allows the insertion of data without a predefined schema. Of course, we'll get into more what that means in a moment here. Okay, but now let's go ahead and let's explore what kind of NoSQL database we're going to be using today. And the kind we're going to be using is called MongoDB. So let's go ahead and start by navigating to mongodb.com, okay, and downloading onto your machine, okay? And this is going to give us access to the Mongo shell, okay? So, as well as MongoDB, we are going to be utilizing something called mlab. So if you don't have an account, you'll need to go to mlab.com and sign up, and they will administer an account for free. Okay, and then from there, we can create a new database. Okay, so let's start off by doing that. Okay, so next, let's choose our version. I'm going to do a cloud provider for AWS, and plan type is going to be sandbox for free. And then I'll choose the location nearest me for the region, and then I'll just name my database. I'll call it CoderCamps DB, and continue. Okay, verify everything's correct, submit, and just like that, we have a cloud database. Okay, so what is mlab? Well, mlab is a cloud provider for MongoDB. Okay, so the idea here is we aren't going to be storing our data on a machine. We're going to be storing it in the cloud. We're just going to be using the shell, the Mongo shell on a machine to communicate with this cloud database. Okay, so let's go ahead and let's click on the database we just created. And let's talk about what's going on down here in our structure. Okay, so a MongoDB database is made up of a series of collections of data. Okay, so you can think of a collection like a category of data. Okay, and within a said category, you have several individual records, which are referred to as documents. Okay, and each of those documents has what's called fields on them, which have corresponding values. Okay, so this is why they are represented in JSON format. So that has to do with, the storing our data. Now here, let's go ahead and talk about users. Okay, so I've got my account user, right, the person I signed up as, but this will be a company or something like that, and users here will be like the authenticated developers, right? So I'm going to add a database user for authentication purposes. I'll also call him Isaac with a password of 123. Okay. So we create our database user, and now we can use those credentials here to connect with the Mongo shell. So let's go ahead and copy this. Okay. And let's open up our command line, and let's paste it on in. Okay. Now I'm just going to scroll back, and I'm going to change out the database user for my real database user. Okay. So I'll say Isaac. And then the database password said was 123. We hit enter, and as we can see, we successfully connected to our cloud database. Okay, so now we can perform different operations. Okay, and the most common operations you're going to be performing on your database are what's referred to as CRUD operations. Okay, so CRUD stands for create, read, update, and delete. Okay, and it's the four main operations that are going to be taking place in our database. Okay, so let's start off by heading to our Cloud DB, and then in collections, let's go ahead and add a new one. Okay, so from here, I'm going to name my collection cars. Okay. And then I can store documents in this collection now. So using our shell here, let's go and insert some cars into that collection. So let's go ahead and say db.cars.insert1, And then let's do a, let's see here, brand, or not brand, let's do type of Tesla. Expand this a bit. Okay. And let's go ahead and let's pass in a year. Okay, and let's say this is 2017. Okay, so as you can see, when we execute that, it inserts a unique ID, right? So now in our MLab, we should have one document with a year, a type, and an ID. Okay, so let's go ahead and let's refresh. And we can see that our cars collection has one document now. As we can see here, it has the type in year, just how we type them out, and then it generates this random unique ID. And this is really great because if we have, say, two Teslas, right, same type or same year, we can still separate those because they have a unique ID. Okay. All right, so now we know how to create data and insert into the database. Let's explore some of the various ways we can query that data, okay, and retrieve it. So let's just start off by talking about, okay, getting all of the data from the cars collection. Okay, and at this time we only have one car, so let's go ahead and make it a little more realistic by adding a couple more cars before we run our query. Okay, so I'm going to say db.cars.insert. And then let's go ahead and we will do type, and let's pass in a Mercedes. Okay, and then the year, let's go ahead and pass in 2000. Okay, and let's go ahead and create one more car. Let's make this one a type equal to BMW. And then let's make it a year equal to 2006. Oops. There we go. All right, so we come back to MLab and we refresh. We can see that we have 3 different cars now, right? Unique IDs, unique types, and years. Nothing to it, right? So let's go ahead and talk about first how we can just retrieve all data from a given collection. So how we can do this is we target the collection, and then we say find, and then we can pass in a filter. But if we leave that filter empty, it'll just find all, right? That's where we return all 3 cars. Okay? So that's if we want all the data. Now, there's going to be specific instances where we want to get more specific about what we want from a collection. Okay, so let's talk about quality, right? And getting values from a given collection or documents from a collection based on, given equality values. Okay, so for example, let's say we want to find all the cars with the type of Tesla. So how we could do this is we could say db.cars.find. Okay, and then we're going to go ahead and find the type and use the bling EQ operand that is equal to Tesla. Okay, and as we can see, it only returns one document from that entire collection. It's the document that has a type equal to Tesla. Okay, and so this is how we can find values, or documents in our collection based on, the equivalence of this value, right? So now let's go ahead and let's explore some comparison operators, right? Greater than, equal to, and how those can help us sort data. So let's say I want to find all the cars greater than the year 2000. Okay, let's go ahead and let's say db.cars.find, and then we'll go ahead and we will pass in year, and we'll pass in greater than operand, and we will say 2000. Okay, we'll close that. Okay, and we can see it only returns 2 cars, right? And that is the Tesla and BMW because they both are greater than the year 2000. However, the Mercedes is equal to the year 2000. So because that's not true, it does not return that document. Okay, so let's go ahead and do the reverse. Let's do less than. Okay, so I'm going to say db.cars.find, and I'm going to find all cars less than 2005. So let's go ahead and say find year bling less than 2005. Okay, and we can see it only returns one car now, and that's the Mercedes. Okay, so depending on what you need, you might want one, you might want the other, or maybe you want both. Okay, and sometimes that will be the case. So if that's the case, you can use a logical operator. Okay, so through logical operators, we can use and or to combine multiple expressions within a query. So let's go ahead and let's set this up. So I'm going to start by trying to find all cars greater than the year 2005 and less than the year 2010. Okay, so we can do this by saying db.cars.find. Okay, and we'll start by saying bling and throw in an array. Okay, the first one is the year that is greater than 2005. And the year that is less than 2010. Okay, so from here, we just need to close our array, and then we'll close our and operand, as well as our expression field. Okay, and as you see, it only returns one document, and that's the document with the year 2006, because it's greater than 2005 and it's less than 2010. But our other cars do not match this, right? So therefore, they do not get returned, and this is the only document that we get back. All right, so just like we can combine them and, you know, evaluate if, you know, both of them are true, we can also pass an or operand in to where if maybe we just are looking for one or another thing, we would use this instead. Okay, so let's say we're looking for Mercedes or Tesla, and we don't really care which one we get. Okay, so we could say db.cars.find. Okay, we'll say bling or. Okay, and let's do type. And I will say Mercedes. Or let's do type bling EQ Mercedes. And then we'll do or type bling EQ Tesla. Okay, so we got that closed up. So let's go ahead and close up our array here, or operand in the expression. Okay, so as we can see, we are returned only two documents, the Tesla and the Mercedes. Okay, because it said go out and find either one of these. Okay, so let's see here. Let's go ahead and let's take a moment to open up the floor, and let's see if anyone has any questions up until this point. Okay, so the floor is open. If you have questions, feel free to ask them now. Okay, I'm going to take that as a no. Let's move forward. So next thing we're going to talk about is projections. Okay, so oftentimes, if we have a database that has lots of activity, lots of queries hitting it at all times, we want to make sure that we are optimizing it, to run the most lightweight operations as possible. Okay, and so in this way, we can use a projection to set up a query for only returning the fields of data that are needed off the document and not the entire document itself. So for example, if I only wanted the year to be returned from my collection of cars, then I would do something like this. I would say db.cars.find. I would find all cars, okay, and then I would pass in the type equal to 1, okay, and 1 represents true, okay, and from here, you can see that it leaves out the year, right? It returns my object, and I have a type for all of them, but I don't have a year anymore. By default, I'm going to get the ID back. However, if I don't want the ID, I can actually manually take that off. Okay, so I can say db.cars.find, pass in an array, or not an array, empty objects, and then we will say to find the type equal to 1, comma, and the underscore ID equal to 0. Okay, so we'll close that up, execute. We can see now that we're only getting the data off the fields we need now, and not just the entire document itself. Okay, so once again, that is what's referred to as a projection. Moving right along, we've learned how we can, create documents, right? How we can read them. So now let's go ahead and explore how we can update them. Okay, so let's say we want to update the Tesla in our database to the year 2018. Okay, so to do this, I'm simply going to say db.cars.find by ID and update. Okay, first thing we're going to pass in, we're going to say what we're targeting. Okay, so I'm targeting the type of Tesla. Okay, and then we're going to set a new value. Okay, so we're going to set the year to the year 2018. Okay, and we'll close that up. And okay, looks like I'm missing syntax here. So yeah, I think I'm using the node script. Let me try db.cars.update1. There we go. Then I'll just say type Tesla and set the year 2018. Okay, so as we can see, it lets us know the modified count is 1, matched count, right? Everything went through successfully. So now, when we refresh, we'll see this turn from 2017 to 2018. And now we've successfully updated our inventory, okay? So that's what we can update using Mongo. So now let's go ahead and finish with learning how we can delete data, okay? So let's just say we want to remove our BMWs. So how I could do this is we'll say db.cars.delete1, type BMW. As we can see, it acknowledges it's successful. So we go back to our DB here and we refresh. You can see that we no longer have that in our database. Okay, and just know that this is a pretty rare practice. Normally, developers don't just delete data willy-nilly. Even when people delete accounts, they tend to just save it, for a certain amount of time. So just know that while you can delete, you want to be cautious because you can delete entire collections and all that fun stuff. So just, proceed with caution in that regard. Okay, so now we've covered all of our CRUD operations. Let's go ahead and let's talk about indexing. Okay, so if there's a field that we are querying over and over again, we notice, that this is a pattern, then what we can do is we can set up an index for that field, and it'll create an ordered copy of that to where it's even faster to query. Okay, so for example, if we go in our MLab and we look under indexes, we can see that there's already one created for _ID, right? Because that's a very common field to query. So let's go ahead and say, well, type is another common field to query, right? So let's go ahead and add an index for that. So how we can do this is simple. We'll say db.cars, create index. Okay, and then let's just go ahead and let's pass in type equal to 1. Okay, as you can see, it acknowledged as successful. So let's go back and refresh our indexes. You can see now type is an index. Okay, so more high traffic situations where you're seeing lots of requests and queries to your database, for a type, this is going to help in the performance because it's going to have an ordered copy here as an index. Alrighty, so let's go ahead and let's wrap up with talking about the concept of a one-to-many relationship. Okay, so a one-to-many relationship really says it all in the title. It's one piece of data that's related to many other pieces of data. Okay, however, these pieces of data are all located in the same database. Okay, so let's go ahead and take a look at a real-world example of a one-to-many relationship in action. Okay, so let's go to yelp.com. Okay, if you navigate to Yelp, you'll see that they have, the category here and, the place here. Okay, so one category is one place is related to, many, I get that backwards. One category is related to many places, right? Okay, so let's go ahead and create our own Yelp app, right, to where we'll have places and categories and we can make a query just like they can, and it'll return all the associated places, right? So I'm going to start off by creating 2 new collections. The first one, let's navigate back to MLab first. Okay, so first new collection I'm going to call is categories. Okay, next collection I'm going to create is called places. Okay, so now let's go ahead and let's populate some places. Okay, so I'm going to go ahead and say db.places.insert 1. Okay, and let's give this place a name of Disneyland. Okay, and let's go ahead and as well give it a category tag of entertainment. Okay. Oh, looks like I missed some syntax here. Yeah, no, I didn't. I forgot to put a comma here. So it did not like that very much. All right. There we go. So as we can see, it inserted that. If we refresh, we can see that we have one place, and excuse me, that place is Disneyland. Category of entertainment. Okay, so from here, let's go ahead and let's set up some other places. So I'm going to say db.places, dot insert one. Let's go ahead and let's use Universal Studios. Okay. And this will be the same category as Disneyland, right? It's entertainment. Okay. Inserted. And now let's do third place, but instead of making entertainment, let's make it a different category. So I'll say db.places.insert one. Then I'm going to insert In-N-Out Burger. Okay, with a category equal to food. Okay, so now we can, easily add our categories and associate the IDs of the places with them. Okay, so how I'm going to do this is I'm going to say db.categories insert one. Okay, and the name of this category will be entertainment. Okay, and then the places associated with this category are going to be put in this array. Okay, so we got the 3 IDs, right, that got generated as far as making our places here. So I'm just going to take the Disneyland ID and I'm going to place it in. I'm going to separate that with a comma, and I'm going to come back to the Universal Studio ID because I know these are both entertainment, so they belong in the same array. Okay, so we'll go ahead and close my array and execute. Okay, so now we exit our places and we go to categories, and we can see that we have the name of the category and the IDs of the associated places. Okay, so let's go ahead and do the same thing for our food category. Okay, we'll say db.insert one name food. And then we'll go ahead and add the places associated to food. Okay, so if we go back to our places here, we can see that In-N-Out Burger is associated. So we'll copy the ID and place it in our array. And oops. Looks like I forgot my collection. I didn't tell it what collection to insert it into. So easy fix. We'll just say db.categories.insert one. Perfect. Okay, so let's go ahead and let's execute this, and that is executed successfully. Okay, so now we can go back and we can refresh. We can see that we have the 2 categories, and they're populated with the place IDs. Okay, so now we could run a very similar query to Yelp. Okay, so we're going to say db.places.find with a category that is equal to let's say entertainment. Okay, so now as you can see, we queried just one collection, and we got all of the entertainment places associated with this. Okay, so let's go ahead and let's query the food category. So we'll say db.places.find category equal to food. And as you can see, it returns In-N-Out Burger. Okay, and just like that, we've created a one-to-many relationship between our data. Okay, so that's really it in a nutshell. Not much to it. So let's go ahead and let's open up the floor, and let's see if anyone has any last questions before we end today. Okay, so the floor is open. If you have questions, feel free to ask them now. Going once, going twice. All righty. Well, thanks again, everyone, for coming. Have a great day and happy coding.